So today we're going to discuss about some additional exercise of electrostatics, and the question is that a charge of 8 millicoulomb is located at the origin. Calculate the work done in taking a small charge of -2 × 10⁻⁹ coulomb from a point P 003 centimeter to a point Q 04 centimeter 0 via a point R 06 and 9 centimeter. So this is the question is all about, and this question tells about that this is a coordinate system x, y and z, and we have to bring a charge from a point P to Q via R, and this is the origin of the coordinate system. At the origin there is a charge of 8 millicoulomb. 8 millicoulomb is equal to 10 to the minus 8 into 10 to the minus 3 coulomb, and there is a point P, there is a point Q, and there is a point R. So I have to take another charge which is -2 × 10⁻⁹ coulomb from P to Q via R. So this is the question is all about. So how we're going to solve it? So now we know that work done from point P to Q is equal to change in potential energy, final point. It is moving from point P to Q. So P point is the initial and Q is the final. So potential at Q minus potential at P. So this is the formula we need to find out. So we need to find out the potential at Q point, and we need to find the potential at P point. So what is the potential at Q point? Potential at Q point with respect to the origin. So that is nothing but 1/4 pi epsilon naught. The charge at point Q and the charge at point origin O. So what is the charge we need to bring from P to Q? That is the -2 × 10⁻⁹. So -2 × 10⁻⁹ into what is the charge at origin? 8 × 10⁻³ divided by what is the distance from O to Q? What is the distance from O to Q? The distance, what is the coordinate of the Q? The coordinate of Q is 0,4 cm. So the distance from O to Q is 4 centimeter. So 4 centimeter convert into meter -2. Okay. Now what about potential at point P? Potential at point P. So potential at point P is the same formula, 1/4 pi epsilon naught. The charge -2 × 10⁻⁹ 10⁻³ divided by what is the distance from O to P? This is 3 centimeter. 10⁻² converted into meters. So this is the numerical, and you have to solve it. What are the terms we can take out? 1/4 pi epsilon naught. These two charges, -2 into 10⁻⁹ into 8 into 10⁻�3. These two are term get common, divided by 10⁻², 10⁻² is common. It will be remain 1/4 minus 1/3. So 1/4 pi epsilon naught is 9 × 10⁻⁹. This 16 minus 10⁻⁻12 divided by 10⁻⁻2, and this is going to be 12 minus 1. This minus become plus. Simplification. So 3, 4, 12. So it's 12 into 10⁻⁻9, and this is 2, this is 10 minus 10 minus 1. That is the answer. That means I can able to write in this way 1.2 joule. That is the answer. Okay, so the next question is a cube of side B has a charged small q at each of its vertices. Determine the potential and electric field due to this charge array at the center of the cube. At the center of the cube. This is the question. Okay, let's draw the cube. So this is my cube in x-axis, y-axis and z-axis. This is my origin. So this is my cube basically. And the side length of this cube is B. B, B, B. Okay. So there is a center of this cube. So we need to find out potential and field at the center. So I just consider a center over here. Okay, this is the center, and I just joined these two vertices, and this is the center. I just name the vertices A, this is B, this is C, this is D, this is E, this is F, this is G, and this is O. I just join the vertex A and D through the center, and if I join this O and D again, O and D, then I can able to find out the triangle A, O and D. Now to find out suppose this point is P, this middle point, center point. Okay, this is C. Okay, P. The center point is P. From the triangle AOP, AOD, AOD. So I can able to write AD square, OD square plus OA square. Okay. Okay. Now, what is the length of OD? We know the length of OA. Now, I don't know the length of OD. So to find out the length of OD, this is base, this is perpendicular, and this is hypotenuse. So OD, OC square plus CD square. OC means B square, CD means B square, twice B square. So OD means what? B root 2. OD means B root 2. Now put the value of OD over here and put the value of OA. So we'll get the answer. So AD square is equal to OD means B into 2, B square into 2, B square into 2, and OA means B square. So there is basically 3B square. Therefore AD is equal to B root 3. This is the value of AD. This is the value of AD. The length of AD we find out. Now this AP is a half of AD. Why? Because this is a cube, all sides are equal, and the center is also at the same distance from all the vertices for a cube. That is why, so AP is equal to half of AD. So half of AD means B root 3 divided by 2. This is the AP. So all the vertices are the same position from the center point P. So therefore AP is equal to BP is equal to CP is equal to DP is equal to EP is equal to FP is equal to OP is equal to B root 3 by 2. All the distances are same. Now the field. What is the field? So all the charges are same at each and every vertices. This charge and this charge will cancel the field over here. This charge and this charge will cancel the field over here. This charge and this charge will cancel the field over here. And this charge and this charge will cancel the field here. So total field will be 0 at point P. Why? Because all the charges cancel each other. Field of all the charges cancel each other. Now potential V. So the potential would be, we have to sum up. So how many charges are there? How many vertices are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices are there. So potential would be 8 into 1 by 4 pi epsilon naught. Charge is q, distance is this B root 3 divided by 2. So this is equal to 8 into 9 into 10 to the power 9 into twice q divided by B root 3. So this is